titration analysis, indicator is usually used to indicate the endpoint of titration. Due to the inconsistency between the actual endpoint and the stoichiometric point, the endpoint error is inevitable. In this lesson, we will learn the endpoint titration error and the conditions for the accurate complexometric titration. The basic expression of the endpoint error is listed as follows. In the process of titration, the excess of titrant causes positive error, and the inadequacy of the titrant causes negative error. Near the stoichiometric point, the majority of metal ions exist in the form of complex My, and the equilibrium concentration of My is approximately equal to the analytical concentration of metal ion CMSP. At the end of the titration, the MPEP is approximately equal to the MYSP, and the difference of solution volume is very small. Since the concentration of metal ions not complexing with Y, M' is very low, the amount of other coexisting complexing agent L which reacts with M is also negligible. So L, alpha M, and K'My can be considered as a fixed value. At this time, except for M and Y, M' and Y', which are not involved in main reaction of titration, the concentrations of the other components are almost constant, and the Ringbaum formula of endpoint error is obtained. From Ringbaum formula, it is found that when the conditional formation constants of the main complexation K'My and the metal ion concentration CMSP is large, or delta Pm' is small, the endpoint error is also small. At the end of titration, if delta Pm' equal to 0.2 and the titration error ET should be less than or equal to 0.1%, it can be obtained from the Ringbaum formula. This is a condition for the direct and accurate titration of a single metal ion M. Ringbaum formula shows that increasing K'My is beneficial to reduce the endpoint error. Therefore, the titration conditions must be controlled. The solution acidity has great influence on K'My, which must be controlled by using specific buffer solution. So, the solution pH should be controlled in which range? At first, we will learn the calculation of highest acidity of solution. Assuming CSP equal to 0.01 mol per liter, according to the condition that we can get log K'My more than or equal to 8. Without considering the side effects of metal ions, if log K'My equal to log Kmy minus log alpha YH more than or equal to 8, then log alpha YH less than log Kmy minus 8. The corresponding pH is the lowest pH, that is, the highest acidity. Plot the maximum acidity of metal ion titration versus log Kmy or log alpha YH. The following information can be obtained from the curve. The lowest pH value for the titration of single metal ion M. When the solution pH is fixed, the possible interference from other ions on the titration of M can be predicted. Usually metal ions with lower log Kmy will be affected by those with higher log Kmy. The separate of continuous titration can be achieved by controlling acidity. For example, the continuous selective titration of bismuth ion at pH 1 and lead ion at pH 5 is carried out. In titration analysis, in order to prevent the hydrolysis of metal ions, the lowest acidity of the titration, which is the hydrolysis acidity of metal ions, must be controlled. The lowest acidity of the system, that is, the highest pH, is obtained by the formula of the solubility product constant Ksp of the product MOHN. For example, In the titration of 0.02 mol per liter zinc ion, according to Ksp equal to 10 to negative 15.3 of zinc hydroxide, the solution pH should be no higher than 7.2. In the practical sample analysis, there are usually coexisting metal ions N and certain complexation with titrant, resulting in titration error in analysis. Now let's learn how to judge whether metal ions M can be accurately titrated without affecting coexisting ions N, that is, the feasibility of stepwise titration. Titration system high acidity. When the acid effect coefficient alpha YH is way greater than the coexistent effect coefficient alpha YN, alpha Y equal to alpha YH plus alpha YN minus 1, approximately alpha YH, equivalent to the absence of N, and log K prime My equal to log K My minus log alpha YH. At the endpoint, if delta Pm prime equal to 0.2 and the titration error ET is required to be less than or equal to 0.1%, it is obtained according to the Rainbow formula log CMSP K prime My more than or equal to 6. Titration system with low acidity. If alpha Yn more than alpha Yh, so alpha Y equal to alpha Yh plus alpha Yn minus 1, new to alpha Yn. Because alpha Yn equal to 1 plus n kny, new to 1 plus kny CNSP, new to kny CNSP. So alpha Y new to alpha Yn, new to CNSP kny. It is knowing that under this condition, log K prime My equal to log My minus log alpha Y. Substitute the alpha Y expression above in the equation, and we can get log K prime My new to log K My minus log alpha Yn equal to log K My minus log CNSP Kny. Thus, log CMSP K prime My equal to log Kmy minus log Kny plus log CMSP minus log CNSP equal to log CMSP Kmy minus log CNSP Kny equal to delta log Ck. According to delta Pm prime equal to 0.2 at the titration end, the titration error ET is required to be less than 0.1%. According to Rainbow formula, we can get log CMSP K prime My equal or more than 6. That is when delta log Ck equal or more than 6. Metal ions can be titrated stepwise. Another condition for accurate stepwise titration in indicator selection. Near the stoichiometric point, at the end of the titration, the indicator may form a stable or same-color complex NiN with a coexisting ion N, which interfaces with the end judgment. Therefore, with a visual method is used to determine the end point, only delta log Ck equal or more than. Cannot eliminate the interference of N to accurately titrate N. It is also necessary to choose a proper indicator. According to the complexation equilibrium between the interference ion N and indicator Rn, Knin equal to Nin divided Nin. The complex amount of N near the stoichiometric point is very small. Therefore, the equilibrium concentration N is approximately equal to the analytical concentration Cn. Usually, when the concentration ratio nRn divided Rn of the complex formed by indicator with nRn to the concentration of indicator Rn is less than 1 to 10, the system presents a clear color of free indicator Rn, and the complex nRn does not produce color interference at the end point. Therefore, the condition that the indicator and N does not interfere with the color judgment of the end point is log Cn K prime Nin equal to log NRN divided Rn equal or less than -1. If the interference ions N and indicator Rn have the side reactions, the above conditions are expressed as log Cn K prime NRN equal or less than -1. From the above three aspects, it is known that in the complex matrix titration, when the indicator is used to indicate the endpoint, in order to realize the accurate titration of M and the mixed ion, the following three conditions must be met at the same time. Log Cm K prime My equal or more than 6, conditions for accurate titration of single M. Delta log Ck equal or more than 6. N does not interfere with titration of M. Log Cn K prime NRN equal or less than -1. N and Rn do not produce color interference. The following is how to improve the selectivity of complex matrix titration. Control the acidity of titration system, that is, reducing the acid effect of titrant and prevent hydrolysis of M. Masking method. According to the type of masking reaction, it can be classified as masking by complexation, masking by redox reaction, and masking by precipitation. Masking method is that a reagent is added to react with interfering ions N to produce more stable complexes, or to have redox reaction with interfering ions to change their valence state, or to produce a slightly soluble precipitate to eliminate interference. The added reagent is called masking agent. The masking method is selected according to the specific titration system. Demasking method. The method is to mask A first, then titrate B, and finally unmask A to titrate it. For example, when zinc ion and magnesium ion coexist, KCN can be added to pH 10 buffer solution, and zinc ion can be masked by reacting with Cn to form ZnCnCn42 negative. So magnesium ion can be titrated with ADTA. Then formaldehyde is added to the solution to destroy complex ZnCn42 negative, and the released zinc ion is continuously titrated with EDTA, achieving stepwise titration. Other complexing agents. When all the above methods are unable to meet the titration requirements, or when the above operation is tedious, we may consider choosing another titrant. For example, log KCAY equal to 10.69, log KMGY equal to 8.69, while log KCAEGTA equal to 11, log KMGEDTA equal to 5.2. So calcium ion can be titrated with EGTA in the presence of magnesium ion. Through this lesson, we have learned the calculation method of the endpoint error of complex matrix titration, the conditions for accurate titration, and the strategies to improve the titration selectivity.